The roulette wheel. This mechanical innovation could either be the cause of enjoyment or despair depending on what is written on it.
All of the possible outcomes are completely randomized. Or is it? Right now, we'll talk about the science behind it. Rotational motion. This is a phenomenon that occurs when an object orbits around a fixed point. One key variable of determining the rotational motion of an object is to get its angular velocity. But what is angular velocity?
What's on the screen right now is a spinning wheel. See the spokes? Suppose that those spokes have a point at the end. Let's say that this point is at 0 degrees. Now if you slowly punch the throttle and observe the time it took for the point to get from 180 degrees. Let's also trace the path in which the point has traveled from one dot to another.
See that the path of the dot is curved. This is because angular velocity measures the change of the object's angle with respect to time.
Time also depends on the force transferred to the object and the object's momentum loss over time.
This means that with the right force and knowledge of where the desired outcome is on the wheel, you could manipulate and dominate the game of roulette. Wait, we're not finished yet. Now, it's time to meet translational motion. Imagine a chess passing a ball to your friend.
The ball is traveling in a straight line from one point to another.
This is because translational motion works slightly different than rotational motion. Here's why.
Let's go back to the ball. Observe that it is still rotating. But now, when we talk about translational velocity, we really want to measure the movement of the object that is moving in a straight line from a point of reference with respect to time.
To put it in simpler terms, translational velocity is the shift of an object from one point in space to another. So now we know that rotational motion is the motion of an object that is in circular path. And translational motion is the motion of an object from one point to another. So where does these two apply in correlation to each other? Yes, you guessed it right. Wheels. The motion of a wheel has both rotational and translational motion. Because without rotational motion, your wheel would simply skid through the ground. And without translational motion, it could result in an old-fashioned wheel.